All right, so the first thing we got to do in 7.2 is we got powers of 10, okay? So we're going to fill in the rest of this chart. So 10 to the first power, that's just 10, right? So that's 10. Then we got 10 to the 0 power.
1.
That's 1, good.
1.
That's 1. And then 10 to the negative 1 power. Yeah, if you use the rule that we had in the last section in 7.1, if you have 10 to the negative 1 power, you would move it. So you would move it to the denominator, and it'd be 1 over 10 to the first. Ethan, stop that, please. I am recording. So it's 1 over 10 to the first power. And then if you do 1 divided by 10 on your calculator, you get just 0.1 or 0.1, right? And then you guys should realize that, like, if you look at, let's look at the next one too, even though it's filled in. If you look at this one right here, according to the rules from the previous section, that would be 1 over 10 squared, right? Or 1 over 10 to the second power. And that's 1 over 100, right? Well, if you read this decimal, right here, if you read it correctly, if you don't, some people read it as 0.01. But you guys are going to remember this digit is in the 10th spot. This digit is in the 100th spot, right? 100th spot. So this is actually 1/100th. Well, that's what we have right here, right? So 0.01 is the same thing as 1 over 100. All right, then it gives you a couple rules here. If you're dealing with powers of 10 and the exponent is positive, it tells you how many zeros will be to the right of 1. So that's, what I'm doing is I'm reading this thing right here. And then if the power on the 10 is negative, you have a negative exponent, you'll take 1 away from the power, and it tells you how many zeros will be to the left of 1, or how many zeros will be in front of 1. All right, so let's just do these. So, actually, I'll start with number 2 here. So 10 to the 4th. So you're going to have a 1, followed by how many zeros? 4, yeah. Because that's that first rule I read above. It said if the exponent is positive, the 4 there, the power, tells you how many zeros you'll have to the right of 1. So you'll have 4. So that would be 10,000. All right, let's look at 1 now. This is 10 to the negative 6 power. So how many zeros am I going to have to the left of 1? It's kind of like take the power and take away 1. So what's 6 minus 1? Kyle? You said it. Yeah, 5. So you're going to have 5 zeros to the left of 1, or 5 zeros in front of 1. So that's going to look like 0, 0, 0, 0, 0, 1. And the decimal will be there. All right? And that should make sense, right? If you look at 10 to the negative 6 power there, well, from the rules from the last section, here, we'll kind of come over here. The rules for the last section, that would mean 1 over 10 to the 6, right? Because if it has a negative power, you move it to the denominator. Well, 10 to the 6th, that is 6 zeros after the 1, right? So that would look like this. So that's 1 over a million. Well, if you read this decimal that I wrote right here, this is the tenths, that's the hundredths, that's the thousands, that's the 10,000s, that's the 100,000s, that's the millions. So it's 1 over a million. Or 0.000001. Kind of makes sense? All right. So let's go ahead and move on. Let's do number Number 3. So this is a 1 followed by how many zeros? Yep. 9 zeros to the right of 1, or 9 zeros after the 1. So it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is like, that's 1 billion, isn't it? Again, I'm recording. Guys, please quiet. If you have something to say, raise your hand. I'll call on you. Now we're going to go the other way. So instead of writing, well, what we just got done with is we were writing the number in standard form, which is actually just writing the number, okay? Well, now this is in standard form, number 4. We want to write it in as a power of 10. So this would be 10 to what power? Yeah, he's got to count the zeros. It's just 10 to the 6th. All right. Then well, we'll do this one. Let's do number 6 first. This would be 10 to the what power? Yeah, you just count the zeros. So it's 10 to the 3rd. That's 10 times 10 times 10 would be 1,000. All right, now the one in the middle there, number 5. Yeah, so you're kind of going backwards from what we were doing before, right? Before you were saying how many zeros were in front of the 1 was the power minus 1, right? So that means this actually needs to be 10 to the negative 4. No, that should be correct. Yeah, well, and now you don't include the negative, but you look at this number right here, and you count, or you take 1 less than that. That's how many zeros you'll have in front of the 1. So you should have 3 zeros in front of the 1, not including this one. All right, not including that 0. Just 3 zeros in front of the 1, and then the decimal point. All right, so then let's see, what do we got here? Is that it for that page? Yes. Okay, so we got to flip it over. So flip it over. Okay. Again, guys, I am recording. I need it quiet, okay? Let's get through this. Shh. Stop the side conversations. Whoever's whistling, knock it off. Quit squeaking. All right, so this is scientific notation. Use this in science class. There's going to be a number, and then it's going to be times 10 to a power, okay? The number needs to be between 1 and 10, which means there will only be 1 digit to the left of the decimal point. If the exponent is positive, so if this exponent up here is positive, let me say this again. The number right here, that part will be between 1 and 10. There will only be 1 digit to the left of the decimal point. The power right here, or the exponent, if it's positive, you move the decimal to the right. So this should say right. And we're talking about the decimal. Okay, we're going to move the decimal to the right. If that exponent right here is negative, please stop. If the exponent is negative, you're going to move the decimal to the left. All right. And then the bottom line of that, this is best used for very small numbers or for very large numbers. And your calculator automatically does that. And that's what they're talking about in this line right here. On the calculator, if you get something on the display that looks like, I'm going to go off the side and explain this over here. If you get something that looks like this, 3e2, that means 3 times 10 to the 2nd power. Okay? Well, then you guys know that's the same thing as 3 times 100, right? So that's going to take the decimal, which is right here right now, right? It's right after the number. It's going to take that decimal and it's going to move it 2 places to the right because the power is positive. So this is going to be a 3, right? The decimal is right there, and it's going to move it 2 places to the right. Well, that's going to move the decimal behind the number. It's going to be 300, right? 3 times 100 is 300. Yeah, so the final answer here is 300. I suppose I could have left it here. Let me draw it like this. Let's leave this part as 3. And then you're moving the decimal from here, you're moving it 2 places to the right. So that's going to equal 300. Okay? All right, so let's go look at number 7 here. So when it says find the value, we're going to write it back in like standard form, okay? So where am I moving the decimal? On number 7. To the right or left? Right. To the right, how many places? 8, yeah. Now the decimal is right here right now, right? So I got to move that 8 places to the right. So it's going to be 2, 3, and then 8, 9, and it was right here, so I got to move it 8 places to the right. So I got to go 1, 2, 3, 4, 5, 6, 7, 8. So that's going to give me a 2, 3, 8, 9, and 6 zeros. All right. So now the decimal's here at the end of the number. That's in standard form. And there'd be a comma there, and a comma there, and a comma there, yeah. That's 2,389,000,000. All right, guys. Number 8. Number 8, right now the decimal is right here. So where do I got to move it? Which way? Left. I got to move it left 3. Remember the exponent's negative on the 10? So if the power's negative on the 10, I got to move the decimal to the left 3 places. So that's going to be, so right now I got 4, 6, 7. The decimal's here. I got to move it 1, 2, 3 places. So I'm going to get 0.467. And if you guys want to think about it, this is a 10 to the 8th. Look at that number 7 again right here. That's a really big number, right? When I multiply 23.89 by a really big number, like 10 to the 8th, I get a big number, right? And then if you look at number 8, if you think of last chapter again, this right here, this 10 to the negative 3 right here, that's the same thing as 1 over 10 to the 3rd, right? Which is the same thing as 1 over 1,000. So I'm really dividing by 1,000. Does that make sense? 10 to the negative 3 is 1 over, remember, if it has a negative exponent, you like to move it. So 10 to the negative 3 is 1 over 10 to the 3rd, which is 1 over 1,000. So when I multiply the 467 by 1 over 1,000, I'm really dividing it by 1,000. So the number gets smaller. This is 467. The answer is 0.467. All right, enough of that. Number 9, which way do I move it? I got 853.4. Which way do I move it? Yeah, you move it to the right because the exponent on the 10 is positive. So I'm going to move it 5 places to the right. So right now it's right here. I'm going to move it 1, 2, 3, 4. So I'm going to end up with 8, 5, 3, 4. So I moved it once. I need 4 more zeros. Like that. I think that's right, isn't it? I moved it 5 places, right? Because now it's right here. 1, 2, 3, 4, 5, yeah. So then there'd be a comma there and a comma there. So that's 85,340,000. Number 10, which way do I move it? To the left, how many places?
2.
Thank you. So right now it's 0.162. The decimal's right here. And yeah, if the exponent on the 10 is negative, I have to move it to the left. And in this case, it'd be 2 places. So that would be 0.00162. That good? All right. Let's see. Is there anything else we need to do right now? The next one, we got to put them in order. Let's see if we can do this really quick. Let's see if I can write these down for you guys. We got to put them in order. So let's write down what these would be. So the first one would be, I got to move the decimal 2 places to the left. So that would be 0.013. The second one, I got to move the decimal 3 places to the right. That'd be 6300. The next one, I got to move the decimal 6 places to the right. That would be 4100000. That is 4,100,000. The next one is this one. Same thing, right? That'd be 2100000. That'd be 2,100,000. The next one, the decimal is right here, so I'm just going to move it 2 places to the left. That is 0.01. And then the last one, I got to move it 3 places to the left. That is 0.0054. Okay, let's just see if we can kind of write over these and number them in order then, just to save some time. So which is the smallest one?
The last one.
The last one. So this one is going to be, let's see, how should I do this? Let's say this one is going to be number 1, right? That's the first one. We're putting them in order from smallest to largest. What's the next smallest one?
The one to the left of it.
Yes. This would come second. Which one would come third? What's the next biggest one after 0.01?
The first one.
The first one, good. That's 0.013, so that one would be third. I'll do this. That's third. That's first. That's second. Then it would be 6,300, right? So that's going to be fourth. Fifth is the 2,100,000. So that would be fifth. And then the largest one would be the 4,100,000. That's sixth. All right. So let's see if we can do this. This is not a story problem. All we got to do is part A is we got to write the diameter in standard form. So we're just going to write this number right here. We got 1.2 times 10 to the 5th. We need to write that just as a regular number. So where do I move the decimal? Where do I move the decimal on this one, guys? Yeah, to the right. So move it to the right 5 spots. So that is going to be 120,000, right? So that's going to be 120,000 kilometers. And now the decimal is here, right, at the end. Okay, and then the last one, we got to put the distance from Saturn to the sun. We got to write that in scientific notation. So right now we got 1,427, comma, 0,000,000. So right now the decimal is right here. Okay, now to be in scientific notation, there can only be one digit to the left of the decimal point. So that means I got to move it 1, 2, 3, 4, 5, 6, 7, 8, 9. It's got to go right there. There can only be one digit to the left of the decimal place in order to be in scientific notation. So that's going to be 1.427. And then we drop all the zeros. And then times 10 to the, how many places did I move it? 9. All right, it's not negative 9, it's 9. Because this is a big number right here, right? If I multiply this 1.427, if I multiply that times 10 to the 9th, 10 to the 9th is what, like a billion? So it's going to be a really big number, as you can see right here. And that would be kilometers also. And that's it. That's it for 7.2.